So let's find the slope of each of these lines. The slope is just equal to the rise over the run, which is just how far it goes up divided by how far it goes over. So this is how I do it. I look and see, okay, where is a point where it crosses exactly on an axis? So as you can see, it looks like it crosses almost on this axis, but that's not close enough for us. We got to find a spot that's just perfect. So there are no perfect spots except for at the very edges of the line. So what we're going to do then is just use this whole stretch. So our rise, the amount it goes up from left to right is, let's see, 1, 2, 3. So our slope is equal to the rise over the run, which is equal to, let's see, it goes from this point to this point, from left to right, it goes up 3, so 3, and then from this point to this point, it goes over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3 over 10. So our slope would be 3 over 10. And that's right. Now this next one, let's see. Well, okay, well this is a good point, so we can start there. Let's look down the graph. Are there any points where it crosses perfectly? No. The only other point that it crosses perfectly is over here. So what we can do is say slope is equal to the rise over the run. Now, how much does it go up from this point to this point? It actually doesn't go up, does it? It goes down. So we're going to say that it goes down 1, 2, 3. So we're going to have to say -3 for the rise because it's going down. Now our run is the same as the previous question. From this point to this point, it goes over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our slope is going to be -3 over 10. Now let's try this next one. Slope is equal to the rise over the run. So we can start here because it looks like a perfect point. Let's look down. Where else do we have a perfect point? That isn't one. Okay, it looks close. This is one here. So we don't have to do the whole thing this time. We can just do this one. Let's see here. So our rise, and it doesn't go up, does it, from here to here? It goes down. So we're going to count our rise is 1, 2, 3, 4, -5. Because it goes down 5 from this point to this point. And then our run is going to be 1, 2, because it goes over 2 from this point. So it's going to be -5 over 2. And that's good for our slope. So all that you have to do is you find the best point on the left, you go to the right until you find another good point, and then you say, okay, how much is it going up? If it's not going up, you just have a negative number, and then it's going down 1, 2, 3. And for the run, it's just how much does it go horizontally. So how much does it go from this dot to this dot? Now, the one thing I wanted to talk to you about is you could actually, on this last one, you could do the whole line. Okay, if we did the whole line, we'll do this in purple. The slope is equal to rise over run. You can do the whole line, but see, the thing is it's more work because you have to count more. So it's better to find points that are closer together. But what we'd have for the rise then would be, let's see, it's not going up, it's going down because it's decreasing to the right. So let's see, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to have -10 over, let's see how far does it go over from here to here. It goes over 1, 2, 3, 4. Yep, 4. Now you can't leave it like that. You need to simplify that fraction. So that's going to equal -5 over 2, which is correct. So you get the same slope, but it's more work if you do the full line. So it's better to just pick a point on the far left that's perfect, and then just work your way and find another point that's perfect, and then just use a smaller section.